Okay, Wednesday we talked about how to take that row echelon form of 3 equations and 3 unknowns and do that back solve. So once we have, that nice stair-step kind of format where the first equation had 3 variables, second equation had 2 variables, third equation had 1 variable, how we solve for the rest of them, we could calculate the back solve. And so here's an example of that. We basically start with z equals 2. Now here z has a coefficient. And before we didn't see z had a coefficient, but here we just divide by both sides by 2, and so we know z equals 2. And then we can calculate y by substituting z equals 2 in the second equation. We get y equals 2. And then we can find x by substituting both y and z in the equation, and so we get x equals 1/3. And our solution then is 1/3 to 2. Okay, so we went over that on Wednesday. Okay, so what we're going to do now is we're going to look at, this is kind of the goal of how we're going to take any general system and put it into this kind of an organization where we have, this the first variable is x, second variable is y in the second equation, and then you have just a z in the third equation. That's row echelon form. So the way we're going to do that is we're going to use 3 basic operations, 3 row operations. One of them is interchanging rows. And so think about that as if I have a set of equations, if I write the first one as the second equation and the second one as the first equation, I'm really not changing much, right? The equations are still the same, the solution's the same. So this just amounts to making whatever's convenient the first one. The reason why you would do this is, let's say you have an equation that doesn't have an x in it, and it happens to be your first equation. Well, you just change it with a row that has an x to start with to get that row echelon form. And I'll go through an example, and most of what we're going to do today is work through some cases here. Okay, the other thing that you can do is multiply through any equation by a constant. So when I have the equation, x plus y equals 1, that I can multiply through by 2 and say 2x plus 2y equals 2. That sort of thing. We can do that to any equation with any value that we choose. And then what we found in elimination, we had added equations together after we've multiplied through to get that common coefficient. We can do that with 3 variables and 3 unknowns in general. So I can multiply, let's say, row 2 by a certain number, and then either add it or subtract it to row 3 if I so choose. So let me give you a couple examples of this. So if the first thing that I do, and look at my notation here, I'm going to take 2 times row 1 and add it to row 2. Okay, so the capital R means I'm going to do the whole row. And so if I do that, I'm going to replace that second row with what I'm going to get from multiplying this times 2 and adding it to this. And then on the third one, what I'm going to do is I'm going to multiply the first equation by 3, by -3, and then I'm going to add it here. And think about what the results of this will be. If I take 2 times row 1 and add it to row 2, my x's will disappear, right? Because I'm going to add 2x to -2x. If I multiply the third row by, or if I multiply the first row by -3 and add it to the third row, then my x's will disappear there. So just imagine in your mind if I were to rewrite that first equation, by multiplying through by 2, if I add the 2 first equations, the x would disappear. So we're actually going to retain that first equation and leave it the way it is, and this will be a little bit of a mental exercise, but what we'll get now is the first equation unchanged, and we'll have 0x plus 4y plus 5z equals 15. So how did I get those? So for the y values now, I'm going to take 2 times y and add it to the second row, which is 2y, and then from that I get 4y. I'm going to take 2 times 2z, which is going to be 4z, and I'm going to add it to z, and that's going to give me 5z. And then I'm going to take, and I have to do the constant side too, so I'm going to take 2 times 4, which is 8, and I'm going to add it to 7, and I'm going to get 15. All right? So just as a little exercise for yourself, see if you can anticipate what this third row is going to be. So you multiply the first row by -3 and add each one. And so you don't have to multiply the whole thing all at once. Multiply it term-wise. So the first one, if you take x times -3 is -3x plus 3x. So the first one is going to be 0x. Okay, so what's going to be the next one? Anybody want to?
13y.
It'll be 13y. And how did you get that?
-4 times -3, and then add the other, or equals 12, and then add the y.
Yeah, it's the other way around.
Or what?
Okay, we're gonna multiply 3 times row 1, -3 times row 1. So I'm going to multiply -3 times this y.
That's the 7.
That would be then -3 plus -4 is a -7y then. Okay? Your revised answer is right. All right, and how about the third one then? I'm going to take, if I'm working on that term, what is that going to be? -6z plus -z is going to be -7z, right? And so if I work all that out, the last one then is going to be 4 times -3 is -12 plus -2 will give me -14. Now, it's traditional when we do this is just to not write the term that has a 0 coefficient. So I could have easily written this with the x's missing from the first two. And if you notice, I'm halfway to my row echelon then, because the second one starts with a negative, or it starts with a 4y, which is what I want in my row echelon form. So I'm going to take this system of equations and I'm going to make it into row echelon form. So I'm going to take that second equation first, and so I'll add equation 1 to equation 2. And notice I've just copied everything over. If I add equation 1 to equation 2, I get x minus x is or no x, 0x, and then 2 minus 1 is going to leave me with just y. And then I have a -z, so that's going to be -1 plus 2 is going to be just 1, so I have z. And then add 6 and -3, and that gives me 3. So that second equation was transformed into y plus z equals 3. Now I just copied over the third equation. You can do this stepwise, or you can do 2 rows at a time like I did on that first one. But going back to the notation that I had before, what I want to do to eliminate that x, and so I want to eliminate x in all the equations, in both equations below that first equation. Notice the coefficients, I'm going from an x to a 2x. If we're doing the elimination method that we did with the 2 variables, you would multiply that first equation by -2 to cancel out the 2x in the third equation. So that's exactly what I'm going to do. I'm going to say, I'm going to take -2 times this and add it to that 2x. And so let me show you the results that I get. I copy the first 2 over, and then, so the x's go away. I take -2 times 2 is -4, and add that to 1. And so I get my -3 for a coefficient. And then I'm going to take my -z times negative 2, which will make a positive 2. Add 2 to negative 4, and so this coefficient is going to be now negative 2. And the last one then, I'm going to take my 6, multiply it by negative 2, and I get negative 12, and add 4 to it, and so I get negative 8. Okay, so I have one operation remaining now. I want to eliminate the y in the third row. So what I'm going to do there is I'm going to multiply the second row, and don't use the first row, because if you use the first row, you're going to reintroduce x, okay, because you have to multiply all the coefficients. And so you don't want to use the first row. You want to use the second row because you're not reintroducing x. You want to eliminate y. And so we're going to multiply this y times 3 to cancel out this negative 3y. And so that'll determine what equation I'm using in the elimination. And so my first two equations stay unchanged. And my last one then becomes z equals 1. So I'll walk through that. Here I'm going to take 3 times 1 is 3, so that gives me a 0y. And then on this one, I'm going to take 3 times z is going to be 3 minus 2 will give me the 1z, or just plain old z. And then I'm going to take 3 times 3 is 9, and I'm going to add that to negative 8, which leaves me with 1, and so I have my row echelon form. So at this point then, you do what's called the back solve. Okay, so this is what we did on Wednesday. From here is we figure out what does y and x equal. We know z equals 1 already. So in the back solve, we'll say, okay, the first equation, that y plus z equals 3, I substitute my z equals 1 in there, and so I subtract 1 from both sides, and I get y equals 2. And then in the next one, I'm going to substitute both my y and my z values, and so I'm going to end up with x plus 3 equals 6, or x equals 3. Okay, so my solution then is 3, 2, 1, and I'm going to make that as a ordered triplet.